Okay, students, now we'll talk about section 10.1, which is angular position, velocity, and acceleration. Now, we will deal with circular motion and angles and angular position, angular velocity, and so on. If we remember that circle circumference is equal to 2 pi multiplied by r, where r is the radius of that circle. 2 pi represent the total rotation, the total angle, which is 360. 360 is equal to 2 pi. We are talking now in degrees, the angle in degrees. If we just take a section from this circle, this section, if we need to find this part S from the total circle, we just need this part, which is S. For the total circle, we multiply the radius by the total angle, which is 2 pi. But now we don't have the total angle, we just have the angle theta. So we need to multiply r by theta to find the length S. We don't need to find the whole circumference, which is 2 pi r. Okay? We need just to find the length of a section, S. Now, for example, if r is equal to 5 meters, and theta is equal to 60 degrees. We will not put theta in degrees here. We need to put it in radians. 60 degrees equal to pi over 3. We will see how we can convert it to this value. So, when we put r is 5, theta is pi over 3, which is equal to 5 pi over 3, which is 5.2 meters. This section. Now, remember that or recall that 2 pi is equal 360 degrees. 1 pi is just 180. This is 180 degrees, which is equal to 1 pi. Pi over 2, which is 180 degrees, over 2, which is 90 degrees. So the right angle is pi over 2, and so on. We will know how to convert the angles. Another example now, if we have S, this section is 100 meters. We don't know the radius of our circle now, and the angle is 270 degrees. 270 degrees means this angle, 3/4. Okay, this is 270. How can we convert it? For each pi is 180. How much 270 in radians? We need just to convert it, as we learned before. We need to multiply by the conversion coefficient. 1 pi in radian is equal to 180 degrees. So this coefficient is equal to 1 pi over 180 degrees. Now we need to convert 270 in to radians. So we want to multiply by pi over 180. Degrees will cancel with degrees. So we have the final unit is in radians. So we have 270 pi over 180 radians, which is equal to 4.71 radians. Okay? Now simply we have S is equal to r multiplied by theta, or theta multiplied by r. We don't know r. We just divided over theta, the both sides. Then r is equal to s over theta. S is equal to 100 as given in this example, and theta is found as 4.71. Then r will be, the radius is equal to 21.2 meters. Okay, now if we need to find the tangential velocity, now we find the tangential length, the tangential distance. What if we need to find the tangential velocity? It is tangential means it is perpendicular to the radius. This is radius. Tangential means perpendicular to this radius. This is V. This is V. If we have S is equal, another example, if we have S is equal to 50 meters, this is S. And delta T is given 5 seconds. How much the velocity, or the speed in this case? It is equal to length, which is S, divided over the time, which is 5. So 50 over 5, which is equal to 10 meters per second. The velocity here, 10 meters per second. We have another velocity for this motion, which is omega. Omega is the angular velocity. We will deal with angles. We know that the tangential velocity is equal to delta x over delta t, where delta x is a length, change in length, over delta time. Now, omega, as we see, it is the change in theta, the angle, divided over the time. So delta theta is equal to theta final minus theta initial. We are given the theta, how much? The theta. So we can take at the initial point t equals 0 and theta equals 0 also. But at the final point here, t equal 5 as we said, and theta is equal to 45 degrees. So we can find omega 45 degrees minus 0 over 5 minus 0, which is equal 45 over 5. This equal to 9 degrees per second. 9 degrees, not radians. We need that in radians. We need to convert 45 to radians. As we learned before, we need just to multiply by over 180 by 45 degrees. The degrees will cancel. Then it will be 45 by over 180. This will be equal to 0.79 radian. In this case, I can use now the change in position in radians to find the velocity, the angular velocity in radians. Now omega is equal to delta theta over delta t, which is equal to 0.79 over 5 seconds, which is equal to 0.16 radians per second. This is omega. Okay, the angular velocity. Now, how much 1 radian? How much 1 radian? We know that we have 1 degree, 90 degrees, 180 degrees, but how much 1 radian, 2 radians, and so on. For a section length, which is equal to, as we see, to radius multiplied by theta, if we take 1 radian, theta is equal to 1, then S is equal to R multiplied by 1 radian, which is theta. Then at that case, S will be equal to the radius. So the definition of 1 radian is when the radius equal to the length of that section. Then this theta, this angle will be 1 radian. How we can find it in degrees? It is simple. 1 radian, we need it in degrees. We need to multiply it by 1, which is the convergence coefficient. We need the radian in denominator and degrees in the numerator. So 1 radian is multiplied by 180 degrees over 1 by radian. Then radians will cancel with each other. Then pi is known, 3.14. So 1 radian is equal to 180 divided over 3.14, which is equal to 57.958 and so on something degrees. This is 1 radian. It is 57.958 and in degrees. Okay, look at these shapes. If we start from here, not from positive x-axis, from the top, we have in radians, in degrees, and revolutions. The 0 degree here, it is the same as 0 radian and 0 revolution. We have 0 revolution at 0. If we have total rotation or full rotation, that give us 360 degrees. This is equal to 2 pi. Also, this is 1 revolution. Okay. 45 degrees is pi over 4 in radians, and it is 1/8 revolution. Look, 1, 2, 3, 4, 5, 6, 7, 8. This is 45 degrees. 90 degrees is equal to pi over 2 in radians and equal 1/4 revolution, and so on. So this is pi equal to 180 degrees, and it is half revolution. You can see this and compare between them. Look for the triangles also. I'll not use this. The summation for the total angles inside the angles for the triangle is 180, but in radian it is pi radians. You can compare the angles between the two triangles. Okay, and 30 degrees is equal to pi over 6. This is the right angle, which is pi over 2, which is 90 degrees, and this is the 180, which is equal to pi. Now you need to be sure how to deal with angles or radians. We need radians. You need to find, we will now calculate the velocity, angular velocity, and the acceleration in the next, but you need to find how to calculate the length of the section, knowing the radius and the angle. Thank you.